centroids and moments of inertia using FX-991ES 570ES Casio calculator 2nd edition. In this example, we have a shape as shown, and we are tasked to determine the coordinates of its centroid and moment of inertia about the x and y axis. To do that, we will enter stat mode using mode 3. We have mode and then 3 for the stat mode. And then, since we are just doing simple calculations, we'll just use the a plus bx linear regression, option 2. So you can use any other regression methods as long as it has x and y variables. Next, already the frequency column is activated here, but if you want to activate it by yourself, we will press the key sequence, shift, and then mode to enter the setup, and then press the down key, and then option 4. And then once you ask if we turn on the frequency, we will turn it on option 1. So now the frequency column is activated in this table. Next, we will input the values as follows. First, we will divide the shape into 3 simpler shapes. In this case, we have a semicircle. We will label that as shape 1. The centroid is here. Here is the table. Now, we have 5 columns here. Only the 3 will be inputted in the calculator. We have the x coordinate of the centroid of each shape, the y coordinate of the centroid, and the area of each shape. And then for the 4th and 5th columns, we have the centroidal, moments of inertia about the x and y axis. For the option 1, we have the x coordinate, which is equal to the radius of the semicircle, or 200. For the y coordinate, so that's equal to this height, which is a, or 200, plus the centroid of the semicircle, which is given by the formula of 4r over 3 pi. So 4 times 200 over 3 pi. And then for the area, so this is 1/2 the area of the circle. So we have 1/2 pi times the radius 200 squared. For the centroidal x, moment of inertia, we have the formula 0.1098 times the radius raised to 4. The radius is 200. And then for the y centroidal moment of inertia, we have the formula 1/8 pi times the radius raised to 4. So that's how we calculate it. Next, for the second shape, we have this large rectangle. We label that as shape 2. The centroid is here on the x-axis. So shape 2 has a x coordinate of the centroid of 200. So that's just the radius of the semicircle. And then the y coordinate is 0 because it lies on the x-axis itself. Next, the area, we have a base of 400, so that's the diameter of the semicircle. And then we have the height of 400, so this is a, 200, plus the radius of the semicircle, which is also 200. So that's 400 in total. So the area is 400 base times 400 height. For the moment of inertia, we have the formula 1/12 times base times height cube. But since the base and the height are the same in value, we have 1/12 times 400 times 400 cube. And that's the same for IY bar. Finally, for the third shape, since we have an excess semicircle included in this rectangle, we will deduct this semicircle. So that is shape number 3. The centroid is here. And in the table, option 3, we have the x coordinate of the centroid equal to 200 as well. So that's the radius of the semicircle. And the y bar is equal to negative 200. So from the x-axis, we go down 200. So that's negative 200. And then we go up by the centroid of the semicircle. Again, it's 4r over 3 pi. So negative 200 plus 4 times radius 200 over 3 pi. For the area, it's the same as shape 1. It's 1/2 times pi times radius squared. However, since we are deducting the shape from the original figure, we will subtract it from the total area. So we will use negative sign for that. Next, for the x centroidal moment of inertia, again, we will have the formula 0.1098 times radius to the 4. But again, since it's deductive, we will use a negative sign. The same with IY bar. So that's 1/8 pi times radius to the 4. And again, it's deductive, so we will subtract it from the total moment of inertia. Once we have the table set up, we can now input the table into the calculator. So make sure that the inputs are correct make sure that the inputs are correct so that the results are accurate as intended. So we have 200 all in the first row, in the first column. And then we have 200 plus 4 times 200 divided by 3 pi. And then we have 0. And then we have negative 200 plus 4 times 200 over 3 pi. And then for the frequencies, we have the areas 1/2 pi times 200 squared. And then 400 times 400. And then negative 1/2 pi times 200 squared equals. So now we have inputted the first 3 columns of the table. So now we will press AC. Again, we will press AC instead of the odd key. Otherwise, your inputted data will be removed permanently. So we'll press AC. Now, let's get the X and Y coordinates of the centroid of the shape. So to do that, we will input this key sequence. We have shift and then stat options 1. And then we will access option 4, which is var. And then we will access option 2. So option 2 is X bar. So that is how the calculator represents centroids or the mean X bar. If we press equals, you will get 200 as the X coordinate of the centroid, which is obviously that's the case because all the shapes have X coordinate of 200. The overall centroid is also 200, obviously. Okay. However, for the Y coordinate, we will press this key sequence. So again, it's shift and then 1 for the stat options, and then option 4 for var, and then option 5 for Y bar. And if we press equals, you will get 157.08 millimeters. Now that is the Y coordinate of the centroid of this shape. And that's how we calculate centroids using the calculator. Next, without deleting the table, we will press AC one more time. So now the table is the input is clear. And then we will proceed with the calculation of the moment of inertia. So first, about the x-axis, we will first input this expression, n sigma y squared, that represents the AD squared in the parallel axis theorem formula. So let's input n, shift, stat 1, and then var, again option 4, and then option 1, which is n, or the total frequency of the entire table. So that's how it is. And then sigma y, let's input shift and then stat and then var again, and then sigma y. So that's the standard deviation of the y values in this table. So 6, and then we will square it to get the variance squared. So that's how we input n sigma y squared. Next in the table is we will add all the x coordinate moment of inertia one by one. So let's start with shape 1. So that's 0.1098 times 200 raised to 4. Let's input that. Okay, and then Next shape, shape 2, we have 1 over 12 times 400 times 400 cube. So let's also input that. Plus 1 over 12 times 400 times 400 cube. And then, lastly, we have the third shape, which is negative 0.1098 times 200 raised to 4. So, times 200 raised to 4. If you press equals, you will get the answer with the 2.45 times 10 to the 9 millimeters to the 4. But why is it to the 9? So let's convert that to engineering notation using the Eng key. Right here, if you press the Eng key, we have now the engineering notation in terms of times 10 to the 9. So we have 2.45 times 10 to the 9 millimeter to the 4th as the X moment of inertia of the shape. Now let's press AC one more time, and then let's calculate the Y moment of inertia. So let's go again to shift and then 1, and then option 4 var, and then for the y-axis we will input the expression n sigma x squared. So don't be confused with this one. For the x-axis it's n sigma y squared, and for the y-axis is n sigma x squared. So that's how the two differ. So let's input option 1 here. So that's n. And then shift 1, 4. And then let's get sigma x, option 3 here. And then squared. And then like usual, we will add the y centroidal moments of inertia of this shape for each shape. So let's start with shape 1. 1/8 plus 1 over 8 times pi, so shape, and then times 200 raised to 4, and then plus the second shape 1 over 12 times 400 times 400 cube, and then for the third shape, so that's minus 1/8 pi, so times pi times 200 raised to 4. Okay, now you can make this easier if you notice that the moment of inertia of the first and third shapes cancel, they add up to 0. So you only need to input the second shape and then make the calculation easy. But nevertheless, the same result. If you press equals, you will get this value, and then pressing the Eng key, you will get this engineering notation, which is 2.13 times 10 to the 9 millimeters to the 4. And that is the moment of inertia about the y-axis of this shape. And that's it for the calculation of centroids and moment of inertia using the Casio calculators. And that's it for our video. I'm Engineer Jaydee, and see you on the next video, mga Ka-Casio Nation.